What's up, everyone? You're watching Everything Weapons. Welcome back to the channel and another video. Smash the like button, subscribe, and let's get right into it. So today I'm going to be reading some news from the warzones.com, so all credit to them. And this is DARPA X-plane designed to maneuver with just bursts of air finally gets its wings. Aurora Flight Sciences and DARPA hope to see the X-65 drone fly next year after suffering delays and cost growth. So Aurora Flight Sciences is now putting the wings on the X-65 experimental drone. This is an important step forward for the X-65, which is designed to maneuver with bursts of air rather than traditional control surfaces. This is technology that could have significant implications for future military and civilian aircraft developments, especially when it comes to stealthy designs. The X-65 is being developed under the Defense Advanced Research Projects Agencies, or DARPA for short, control of revolutionary aircraft with novel effectors, or CRANE program, which kicked off back all the way in 2020, and DARPA subsequently chose Aurora Flight Sciences, a subsidiary of Boeing, to proceed alone with the development of its design, and Aurora moved into the latest phase of the program in 2024 and is now targeting a first flight next year for 2027, and CRANE has suffered several delays and cost growth over the years, which we will come back to on later. But the wings have arrived, the next big milestone for the X-65, Aurora Flight Sciences wrote in a post on its official account on X or Twitter today. Built at our WV West Virginia facility, the triangular wings enable active flow control testing across multiple sweeps. Integration is underway in Virginia as we push forward first flight for the DARPA CRANE program. So in November of 2025, last year, Aurora had also announced progress in construction of the central fuselage, and the company also done wind tunnel testing of subscale models, as well as digital modeling in past phases of CRANE, and the X-65 has a so-called co-planar joined wing, or CJW, platform that includes two sets of wings attached that merge together at the tips, creating the triangular shape on either side. They also have small extensions that extend from those tips, giving the drone a 30-foot wingspan. The design also has a twin vertical tail arrangement. There is a chin air intake under the forward fuselage, as well as a single exhaust. Renderings have shown that the design will have a top T-op of the forward end of the fuselage. At the time of writing, neither Aurora nor DARPA appear to have disclosed details about the drone's main propulsion arrangement, and the X-65 is said to have a gross weight of about 7,000 pounds. And as noted, the most intriguing aspect of the X-65 is the banks of active flow control, or AFC, effectors that use bursts of highly pressurized air to roll, pitch, and yaw. Traditionally, fixed-wing aircraft use a mixture of flaps, rudders, and other surfaces that physically move to maneuver in flight, and the AFC system supplies pressurized air to 14 AFC effectors embedded across all flying surfaces, according to a press release Aurora put out last year. The triangular wing design enables testing across multiple wing sweeps and is modular with replacement outboard wings and swappable AFC effectors to allow for future testing of additional AFC designs. The X-65 will be built with 2 sets of control actuators, traditional flaps and rudders, as well as AFC effectors embedded across all the lifting surfaces. A 2024 press release from DARPA also notes this will both minimize risk and maximize the program's insight into control effectiveness. The plane's performance with traditional control surfaces will serve as a baseline. Successive tests will selectively lock down moving surfaces using AFC effectors instead, and the X-65 conventional surfaces are like training wheels to help us understand how AFC can be used in place of traditional flaps and rudders. Dr. Richard Wisselen, then the Crane program manager at DARPA, also said at the time, "We'll have sensors in place to monitor how the AFC effector's performance compares with traditional control mechanisms, and these data will help us better understand how AFC could revolutionize both a military and commercial craft in the future. We're building the X-65 as a modular platform. Wing sections and the AFC effectors can easily be swapped out to allow to live on as a test asset for DARPA and other agencies long after Crane concludes." And being able to eliminate traditional moving control surfaces presents a host of potential benefits. Getting rid of traditional control surfaces inherently allows for a design to be more aerodynamic and therefore fly in a more efficient manner, especially at higher altitudes. And an aircraft with a AFC system doesn't need the various actuators and other components to move things like rudders, offering new ways to reduce weight and bulk. A lighter and more streamlined aircraft design using AFC system might be capable of greater maneuverability. This could be particularly true for uncrewed types that also do not have to worry about the physical limitations of a pilot. The elimination of so many moving parts also means fewer things that can break, improving safety and reliability. This would do away with various maintenance and logistic requirements too. It might make a military design more resilient to battle damage and easier to fix as well. All of this could be especially valuable for stealthy aircraft designs, while all of this could be beneficial for many aircraft types. AFC technology could be especially significant when applied to stealth designs. Designers of stealthy aircraft have to be mindful of any joints or other gaps between exposed surfaces and try to generally keep them to a minimum to ensure the radar cross-section remains as low as possible. As such, traditional control surfaces, which by definition cannot always be flush with the rest of the aircraft's external shape, are a major and currently inescapable issue. Fly-by-wire designs also keep these surfaces fluttering at all times to keep the stealthy aircraft stable in forward flight. AFC technology holds the promise of being able to change this reality and make it easier to optimize the radar evading qualities of a stealthy design. Other technologies, like the ability to dynamically warp wing structures to provide flight control, could also help in future stealthy aircraft radar signature control. A design like the X-65 that has the option of using either traditional control surfaces or AFCs could offer further flexibility. Deeper exploration of the potential of an AFC design is exactly the point of DARPA's Crane program, which is now aiming to kick off actual flight testing next year in 2027. As mentioned, there have been multiple delays in work on the X-65 over the years, and the original goal was for the drone to fly for the first time in 2025 last year, which unfortunately didn't happen. The costs to produce the prototype aircraft for test flights ended up being higher than expected, and DARPA chose to strategically pause the X-65's development and reevaluate the program. As this was reported in November 2025 of last year. And Aurora also confirmed technical and supply chain challenges were a factor in the program delays, as well as the inherent riskiness involved in working on a DARPA project. It should be noted here that this is not the first time AFC technology has been experimented on with UK headquarters BAE Systems, BAE Systems, which also submitted a design for Crane, tested a flying subscale AFC equipped design called Magma in the 2010s. And the Pentagon budget documents show that DARPA has received nearly $63 million in funding for Crane since fiscal year 2024, when the program entered its third phase. DARPA is not asking for any additional money for this effort in fiscal year 2027 next year, which it says reflects the expectation that it will conclude by the end of next year. As DARPA has said in the past, future programs could further continued use of the X-65 drone, as well as the technology it demonstrates. We're excited to continue our long-standing partnership with DARPA to complete the build of the X-65 aircraft and demonstrate the capabilities of active flow control in flight. Larry Worsing, Aurora's Vice President VP of Aircraft Development, said in a statement last year in 2025, quote, "The X-65 platform will be an enduring flight test asset, and we're confident that future aircraft designs and research missions will be able to leverage the underlying technologies and flight test data." With its wings finally delivered, the X-65 drone continues to take shape as Aurora and DARPA push towards finally getting the drone and its novel control arrangement into the air. All credit to Joseph, the deputy editor at thewarzone.com. If you guys enjoyed watching or learned something, please smash the like button. A thumbs up and liking the video really helps me out a lot, pushes my videos and content to other eyes and other audiences. So thank you very much for watching. Subscribe, ring the bell, that way you don't miss any videos I post in the future, and check out my older stuff on the channel as well. Lots of videos to binge watch, military news, history, weapons stuff. And once again, you've been watching Everything Weapons. See you guys in my next video. Take care.